Hi everyone, welcome to the video for chapter 13, Polymers. So at the beginning of this chapter 13, let's look at some of the definitions of the terms that we are going to use. So first of all, we have monomer, polymer, and repeating unit. So for monomer, it refers to the molecule from which a polymer is synthesized. Polymer refers to a large molecule which is made up of many repeating units of monomers. And repeating unit is the basic structures of a polymer and by repetitions to produce a long polymer chain. Make sure you are able to differentiate between three of these terms. Based on the diagram given over here, you have your monomer, which is your starting reactants, and when it undergoes polymerizations, you are forming a long chain of polymer. So all of these units, we call it as the repeating unit. So for an example, we have the monomer ethylene. So when it undergoes polymerizations, you are forming a long chain of polymer. So we represent this polymer using a bracket and numbers of n. This number of n represent the numbers of monomer. Next, let's look at the terms homopolymers and copolymers. So homopolymers refers to the polymers that make up of identical monomers. So for example, you can see over here we have the formations of PVC, polyvinyl chloride, which is made up of only one monomer. Whereas for these copolymers, it refers to the polymers that are made up of two or more different monomers. So at the examples at the bottom here, you have two different monomers, which when undergo polymerizations, it form a long chain polymer. And we have also straight chain polymer and cross-linked polymer. So straight chain polymers refers to the polymers that have long continuous polymer chain in their basic skeletal structures, whereas for cross-link, it has three-dimensional structures in which the linear polymer chains are connected by the bridge or cross-linkage, as shown in the diagram below. The next polymers is categorized into natural polymers and synthetic polymers. So for natural polymers, we can find it naturally. So for example, for the proteins, the meats, carbohydrates, starch and cellulose, and natural rubbles. One of the natural rubble, they have a name isoprene, which also called as cis-poly 2-methyl-1,3-butadiene. Whereas for these synthetic polymers, usually it is prepared chemically from the monomers. In order to form a polymer, it must undergo a process called polymerizations. This is a chemical process of joining together of monomers to make a long-chain polymer. And there are two different types of polymerizations. First of all, condensations polymerizations, which is also known as step growth polymerizations. In this condensations process, a chemical reaction in which two monomers will join together to form a large molecule, and at the same time, it will eliminate a smaller molecule such as H2O, HCl, and a molecule of methanol. So in this condensations polymerizations, it involves the formations of polyester, which we have the ester linkage, and polyamide, which we have the amide linkage between molecules with two functional groups. So the examples of polymers, we have polyamides and polyester. The second types of polymerizations is addition polymerizations, which is also known as chain growth polymerizations. This is a chemical process in which monomers with one or more multiple bonds are joined together by covalent bonds to form a larger molecule without the loss of a small molecules. And in this addition polymerizations, an initiator is required. An example of initiator is a peroxide. Let's look at the first type of polymerizations. We have this condensations polymerizations. So the example, polyamides. And in this polyamides, we have a common example, which is Kevlar, Nylon 6, Nylon 6,6. For these polyamides, they are polymer in which individual units are joined by amide bonds or amide linkage. To form a polyamide, it must involve two functional groups. Either it is formed when a carboxylic acid with two COOH groups react with an amines with two NH2 groups. Or it can also form when a compound containing both COOH groups and NH2 group. So it must involve two different functional groups. Whereas for this polyester, the common example we have is dacron, tellurine, or PET. So the repeating functional groups in this polymer chain are ester, joined by ester linkage. So this polymers is formed when a carboxylic acid with two COOH or COOR and ester group react with an alcohol with two OH groups. So also it involves two different functional groups here. Or it can also form when a compound containing both COOH or ester together with the OH group. So remember that for condensations polymerizations, there will eliminate a small molecules to form this long chain polymer. So let's look at the example of this polyamide. We have Kevlar, Nylon 6, and Nylon 6. So first of all, Kevlar, which is an aromatic polyamide, is used for making bulletproof vests, anchoring cable, reinforcing fiber, and fireproof garment. So this is the uses of this polyamide Kevlar. So the formulas we have over here is the monomer 1,4-benzene dicarboxylic acid, 1,4-diaminobenzene. So when both of these monomers undergoes condensations polymerizations, it's forming an amide linkage. From the carboxylic acid, we are removing the OH from both ends, and from the amines, we are taking out these hydrogens from both ends as well. So you are forming N molecules of water as the side product. Next example, we have Nylon 6. So for this Nylon 6, the common uses is to make a strong and flexible fibers for ropes and tire cord. So for this Nylon 6, you need to remember about its monomer. It is a cyclic structure, and when it's undergo polymerizations, it open up into a straight chain polymer, in which it evolved two functional groups. Okay, here you got the amines, amino, and then over here you have your C double bond O, which come from your carboxylic acid actually. Okay, so condensations, you remove N molecules of H2O. Next example of polyamides, we have nylon 6,6. So this nylon is used in many products, including parachutes and clothing. So it involves hexane dioic acid and 1,6-diaminohexane. So N molecules of dioic acid and N molecules of this amine. And when it undergoes condensations polymerizations, it forms a straight chain polymer. And over here, you have this amide linkage in between. Okay, so imagine the same thing for this carboxylic acid, take out the OH from both ends. And then for this diamino, take out the hydrogens from both ends. So we are forming N molecule of H2O. Also the same thing, to form this nylon 6,6, you can also use this hexane diol dichloride. So that means the positions of the OH you can use as the acid chloride. Okay, C double bond OCl for both ends. So that imagines that the chlorine combined with the hydrogens from this diamine from both ends, you are producing the side product HCl. Okay, it's either H2O or HCl as the side product. The polymer is still the same. Next, let's have a look at this polyester. The first example, dacron or tellurine. So for this polyester, dacron or tellurine, you can use to make clothing fiber, for example, jackets, some jersey. So for this dacron or tellurine, we are using dimethyl terephthalate, diester, so C-double-bond-O-C, and it reacts with another monomer, ethylene glycol, and structures containing two OH groups, so undergoes condensation, and you're producing an ester. So for this bonding is our ester linkage. Imagine that from this diester, we are taking out the CH3O, and then it combined with the hydrogens from this alcohol, and you're producing a small molecule or the side product of a methanol. The next example, you have this PET used to make bottles or container. So again, this one is coming from your dicarboxylic acid, structures with two OH group at the end. So OH coming from your dicarboxylic acid and then hydrogens from this alcohol, and you're making a polyester. Okay, so this is your ester linkage, and you're producing the side product H2O. So let's look at this example questions number 1. Identify the monomer for the synthesis of the following polymers. So for this nylon 610, you can see that there is an amide linkage between these nitrogens and the C double bond O. Okay, so here is your amide linkage. From the linkage over here, you can identify it's made up of two different monomers. So one is diamino, okay, the diamides, and another one is either a carboxylic acid or acid chloride. Okay, so breaking out the bonds over here, so imagine that you put back one of the hydrogens, so you are getting a diamine. Okay, and for another monomer, you're getting a carboxylic acid. You can also replace the OH with Cl. Okay, so two monomers, this is your copolymer. Okay, different monomer. Alright, for the second structures over here, you can see a C double bond O, O. Okay, so here is your ester linkage. Okay, this one is your ester linkage. So you can identify the first monomer and the second monomer. Okay, two monomers involved. So for the first structures over here, you just imagine that you replace back the OH at both positions. So you get a dicarboxylic acid. Or maybe you want to substitute the Cl over here. Okay, both accepted. And then the other structures will be an alcohol. Okay, two OH groups, so involving two different functional groups. So for example, questions number 2, polylactic acid PRA is formed by polymerizations of 2-hydroxypropanoic acid. Write an equations for the polymerizations equations and draw its repeating units. So this is lactic acid, and over here you can see a COOH functional group, and here you got a hydroxy functional group. So from the COOH side, carboxylic acid, you take out the OH, and from the alcohol side, you take out the hydrogens. So now you can imagine you have a side product H2O. So after removing the H2O, there is N molecule of H2O. Remember, if you want to write an equation, there is an N in front of this monomer. N molecule of monomer undergo polymerizations to form this polymer, big bracket with the N and N molecule of H2O. So for the repeating units, it's the same as this polymers, but without the letter N.